Okay. And the fences, basically, we take the width of the box. What is the width of the box? The IQR, because it's the difference between Q3 and Q1. That's the IQR. That's the width of a box. And we basically do 1.5 times that, and we go out in either direction. So we take this width of the box, we go out 1.5, and we create an invisible line over there, which forms a fence, and we go over in this direction, 1.5, somewhere over here. So the fences, there's two of them. There's an upper and a lower. The upper fence is we take Q3 and we go an additional 1.5 times the IQR. And then for the lower fence, we start at Q1 and we go down 1.5 times the IQR. And for the longest time, our textbook, maybe they fixed it in this. Yeah, okay, they did. They had a typo. So we had 1.5 times the IQR. Okay? And so the fences kind of separate what we consider the usual from the unusual. And so if we have any data points that are outside of the upper and lower fence, we would consider these outliers. The rule for what is an outlier and what isn't an outlier should not be so straightforward. Okay, there's always a little bit of mystery and judgment in deciding what is an outlier and what isn't. Okay, it's just like trying to decide, is someone, does someone have depression or are they sad? Just a little bit more sad than other people. It shouldn't just be like, oh, we check off these things, you scored 5, so you are this, you scored 7, so you are this.
Is it possible to determine the IQR from the box plot?
Yeah, you just look at Q3 and Q1, and that would be your IQR. Yeah. Okay. But yes.
According to the definition for fences, does that mean, theoretically speaking, the length of your whiskers are always the same because IQR is a constant?
No. Okay. So yeah, let me explain this. So the location of the fences are always going to be determined by this, but these are imaginary lines that are kind of like, if it's beyond this, it's probably an outlier. If it's not beyond this, it probably isn't. Okay. And at this point in your journey of statistical discovery and things like that, this is probably going to serve as a good rule. All right. If it's bigger than the upper fence or smaller than the lower fence, it's probably an outlier, and you can just say it's an outlier. And if it's within these fences, we will consider this normal data, or just things that are not unusual. Okay. As you gain more experience, then you might find some dissatisfaction with these fast rules. Okay. But we do stuff like this all the time. We say, as soon as you turn 18 years old, you can smoke and vote and do all of these things. Whereas if you are 17 years and 364 days old, you are not legally allowed to do these things. Does something magical happen on your 18th birthday? No, but we have to set up some kind of line that distinguishes one from the other. And that's all what these fences do. So if it's beyond the fences, they're considered outliers. If they're not, we consider them probably usual. The whiskers don't go to the fences. They go to the largest and smallest points within the fences. So if you have data that ends here, that's how far the whisker goes. Okay, you don't take it all the way to the fence. Okay, so maybe we will try making a box plot ourselves. Let's see how we can do this. Okay. Okay, so let's say a bunch of people took a test, and so this was a score. You can 0 to 100%, and let's say the test scores were 10, 20, and then 55, 65, 70, 72, 6. Okay, so 12 people took a test, and let's say these are the scores. Okay, let's make a box plot. So to create a box plot, we have to figure out Q1, the median, and Q3. This is the very first steps in making a box plot. Okay, so what is our median? Okay, so we have 12 numbers, so wherever our median is, we would have 6 numbers larger and 6 numbers smaller, okay? And so our median is halfway between 72 and 80, and that would be 76. Good? Okay, so where is Q1? Okay, so if we have these 6 numbers, we're going to take the spot in between there and there, and so our Q1 is 60. In Q3, halfway between there and there. So that would be 87.5. Alright, so we'll make a number line, and we'll start off at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So Q1 is at 60. I'm going to form a line right there. The median is at 76. I'm going to put a line right there. And the Q3 is at 87.5. So this forms my box. Okay. If you had a situation where a whole bunch of people had the same score, and so maybe Q1 is the same as the median. Okay, is that possible? Is it possible for Q1 to be 70 and the median also to be 70, depending on your data set? Yeah, of course that's possible, okay? And so even possible for Q1, the median, and Q3 to all be 70 or something, you know? That would mean a whole bunch of numbers are 70, but that's possible. And if that's the case, it would just appear like there's only 2 lines, or 1 line, okay? Your box would just be, you know, if Q1, Q3, and the median are at 70, your box would technically look like that, okay?
Would there then be no fence?
Yeah, if Q1 and Q3 are the same number, then your IQR is 0, and therefore your fence would be at 70 also, okay? Okay, so this forms our box here. So what is our IQR? Our IQR is 87.5 minus 60, 27.5, okay. And so I go 27.5 times 1.5, what is that? 42 something, yeah. Help. What is it?
41.25.
41.25. Okay, so I would start at Q3 and I would go out 41.25, and that would extend, you know, to like 129.75, okay? So my upper fence would be 87.5 plus 41.25, so that's like, you know, like 128.75. And then I would take 60 and I would go down 41.25, okay? So 60 minus 41.25 would be, what, 18.75? So the lower fence would be 60 minus 41.25, 18.75. Something like that. Okay. So what does this tell us? Our data, the whiskers would go to the largest point within the fence, which is 97 over on this end. What is the smallest data point that I have within my fence? 20. 20 is still considered, quote, normal, according to this, and it looks like that. But then this poor guy who scored 10%, he is indicated with an outlier. And this is what our box plot looks like. How are we feeling about that? Okay. And looking at a box plot, we can look at other box plots and compare them, and we would get an idea of where the center and where Q1 and Q3 are. We would get a general idea of where the points are located. Are they large or are they small? We also get an idea of the spread by looking at the IQR and also looking at the length of the whiskers. So if the whiskers only go out this far and the box is this small, then that would indicate small spread. If we see a wide box, that would indicate large spread. The shape, we can get an idea of skewness by looking at the length of these whiskers or tails, okay? So this would indicate that we have a left skewed distribution because this one is so much longer than what we have over here. Okay, so if we technically look at where your median is, and if this side is much longer than this side, then that would indicate you've got skew in the left direction. Also, if you have outliers on one side and not the other, that would also indicate skew in that direction. So a box plot gives us an idea of the center, the spread, anything unusual, and also the shape. What you don't see in regards to shape is you don't see if it's unimodal or bimodal. The number of peaks is lost when we're talking about a box plot. Okay? So you don't know if you have unimodal or bimodal distribution or multimodal. Okay? That is lost with the box plot. But everything else should show up. Okay. So in your homework for the weekend, you will have a few exercises where you are presented with different box plots, presented with a few numeric summaries, and you're going to be asked to use these things to make comparisons between different distributions of data. Okay. All right. And so once again, for the lab that's due tonight, just turn in what you have, answer as best as you can. We'll give everybody full credit, and if it looks like you've successfully done the stuff with R in RStudio, we'll give you some extra credit for that. Okay, so don't freak out. And I'll try, next week's lab, I'll try to make it work for everyone, okay? Okay, we'll see you guys on Monday.